Okay, so basically, one of the requirements of this project was to create a network topology using Cisco Packet Tracer. And as you can see on the screen, the software that we used is indeed Cisco Packet Tracer. And in that regard, we used Packet Tracer version 8.22. So for you to open this file, actually you should have 8.22 version and above. Yeah. So I think that's clear. The first point of technological requirement that indeed we had on the project requirement. So another thing that was required from the project was just a minute. Yeah, so another thing that was required here on the project was to implement hierarchical network design. Hierarchical network design is a network design where we have the core layer, the distribution layer, and the access layer. So in this design, we adopted what's called a two-tier hierarchical network design. When I say two-tier, two-tier, some people say two-tier, or some guys say two-tier. So T-I-E-R, two-tier. So let me just say two-tier. So when I say two-tier, the two-tier, in the two-tier design, both the core layer and the distribution layer are combined or are placed together. Then the access layer is on its own. Yep. So when we start from the access layer is where we've segregated the departments. You can see we have can I share my screen instead so that I highlight them as you're seeing. Yep. So just a minute. I think it will be clear when you see it from my hand, and I'm maybe touching what I'm explaining. Yep. So, yep. Can you see my screen now? Okay. All right. So, like I was saying, that the first requirement was to ensure that this is actually the project, the project 10. So, just remove this one here. Yeah, this project 10 that we want to talk about today. And the first requirement, under requirements, technology to be implemented. The first requirement was actually to create network topology using Cisco Packet Tracer, of which you did here. And the second requirement was to implement hierarchical network design. Well, like I was explaining that in this topology, the hierarchical network design has been implemented in form of a two-tier network design. Well, in two-tier, both the core and the aggregation or distribution layer has been combined together. So this is where we have implemented both core and aggregation layer. And below it, this is now access layer, where the access switches are and the end devices. Yep. All right. So another thing that we were to implement there is connecting network with using correct cabling. Well, it's very, very important that we use proper cables when connecting to networking devices. So for example, for end devices, we've used what's called straight through cables. You can see this is a straight through cable connecting to from the computer or the IP phones or the printers to the switch here. But now when connecting switch to switch, we are using what's called crossover cables, because crossover cables is used to connect devices of the same point, the same kind, or the same same kind. Yeah, that's okay, right? And then we are using straight through cable to connect between the multi-layer switch and the firewall. Also from the firewall to router, we use a crossover. A router to, the ISP to cloud, we use crossover. Yep. So I think you've actually know which type of cable to use. Configuring basics, configuring basic device settings. Well, there are a lot of basic device settings that we've done on these devices, starting from the access switches, multi-layer switch, the firewall. This is an ISP router. For the ISP router, we do not have control over it. So it's the ISP company that manages this router. So we don't need to configure any basic settings here. Yep. All right. So we are going to explain that practically again. So the first phase is just to do it theoretically. All right, creating VLANs and assigning ports VLAN numbers. All right, so based on this design, you can see clearly that each okay. All right, so based on this design, we had various VLANs. Here we had wired users. That's a VLAN name. We had Wi-Fi users for VLANs and IP phones. So DMZ, I don't think if we configured it with a VLAN number. So people who are connected via cables are in a different VLANs than people connected via Wi-Fi. As well as IP phones are in a different VLANs from the wired computers or printers. We are going to do that practically. So the first step is just to understand what I did. Then also creating both data and voice VLAN. So like I've just mentioned here, we had both data and voice VLAN. So voice VLAN is used for IP phones. So in this topology, we have IP phones here. We have IP phones in every department. So for IP phones, we need a voice VLAN. But for computers, phones, smartphones, laptops, we need data VLAN. Yeah. So here we had wired users and wireless users. Those are data VLANs. But IP phones, voice VLAN. Okay, another thing, subnetting. Well, sorry. In this topology, we were actually required to put wired users in a different subnet than wireless users. So, for example, someone who connects via a cable gets a different IP than someone who connects via Wi-Fi, as well as people who connect via as well as IP phones, they should be in different network or subnet. For DMZ, I'll talk about it later. So we have just ensure that the LAN, the wired LAN, that's the subnet. The wireless LAN, this is the subnet. IP phones in the entire network, this is the subnet. As well as DMZ, this is the subnet. All right. So number 8, configuring inter-VLAN routing both on switches and routers. Okay. So in this topology, as long as we have VLANs in any network, then it's a requirement that we implement inter-VLAN routing to enable devices in different VLANs to communicate with each other. So we implemented 2 types of inter-VLAN routing. One is called switch virtual interface, SVI. Another one is called router on a stick. So for switch virtual interface, it was particularly done for data VLAN. But for router on a stick, it was particularly done for voice VLAN. So this is where we implemented SVI, switch virtual interface inter-VLAN routing protocol. So the inter-VLAN routing configured here will control all these computers, laptops and smartphones, both the wired and wireless LAN. But here you see this voice gateway. This is where we've implemented what's called router on a stick. So router on a stick is a type of inter-VLAN routing that we've used here to control the IP phones. So the IP phones are only controlled by this router. That's why we call it Cisco Voice Gateway. So we have to do everything here. Every configuration, we need to do it here. So we implemented what's called a router on a stick here to control the IP phones in the network. Okay. So configuring the dedicated DHCP server for data, okay, for data VLAN. All right. So in this topology, we had a DMZ here. So in the DMZ, we had AD server, Active Directory server. So the Active Directory server will act as our DHCP server in the network. So this is the DHCP server. We've configured the DHCP AD server to be our DHCP server and provide dynamic IP addresses to computers, printers, and these wireless devices, but not IP phones. IP phones, they're controlled from this point. Right, so configuring DHCP server for voice VLANs for IP phones. Like I mentioned, for IP phones, this is their DHCP server, the voice gateway. So the IP phones get their IP address from this guy here, from the Cisco Voice Gateway. Right. So configure spanning tree protocol, HTTP, BPD UGAD. All right. So basically, in every design, in a normal scenario, when you try to, let me just try to plug out this cable here. That's F. If I could just put my cursor over that green blinking icon, you will see the port there is FA015. So in a normal scenario, if you try to connect your computer to any available interface, that computer actually it will take like 30 seconds, 30 to 45 seconds before this before this icon turns green. It normally starts from red, orange, then finally to green. Before it turns green, it takes like 30 to 45 seconds. That's time consuming. So to prevent that long transitioning, we need to implement what's called port first and BPDU guard. So port first will enable this interface to turn green immediately it feels there's something connected. But BPDU guard will enable it to prevent any loops. So this port will only be used for connecting end devices, but not switch to switch. So if you connect it switch to switch, BPDU guard will shut it down. So that's why we need to implement the two together, port first and BPDU guard. All right, so another thing, configuring Active Directory as DHCP server. I think I've explained that in this network, the Active Directory here acts as our DHCP server for these end devices, computers, laptops, and wireless devices, as well as printers. But for IP phones, it's this guy here, Cisco Voice Gateway. And another thing here, configuring SSH for remote access. Well, in every network infrastructure, you will need to remotely configure your devices. You don't need to go to the server room or the data center, put the cable on the switch, put a console cable on the switch, and to your computer, then start configuring. Well, it's pretty much simple if you do it from where you're seated on the desk. You just sit on the desk, you just search by the switch IP, you input your credentials, and you start configuring. So in this regard, we have implemented SSH in all these devices, all the three switches, the monthly switch here, the voice gateway here, the firewall, as well as this switch. Like I said, from this point we don't manage them, and we only put them here for testing purposes. This is ISP router managed by ISP companies. This is cloud. We don't manage it here. We just put it there for demo purposes. And also these are components in the cloud. Yep. All right. Okay. So another thing that we need to include there is OSPF. Well, OSPF is always a standard routing protocol that is being used widely in the market. So I have implemented OSPF in all these layer 3 devices. When I say layer 3 device, we start with the multi-layer switch here. We go to the router here, the firewall here, and also here. So I implemented those OSPF there just to ensure that our traffic reaches this point. Although we should not manage them, they should be managed by the providers. But for demo purposes, we just provide minimal management, like configuring our ISPF and IP just to allow passage of the traffic. So OSPF is the routing protocol that has been used in this network, only OSPF, that will enable data from one point or from one network to go to another network. So number 15, configuring standard ACL for VTY interface to restrict remote access using SSH. Just like I mentioned that we need to configure SSH such that we can remotely access our devices in the data center. We don't need to go there physically, but we need to think twice. We don't need to leave it open for everyone. We just need to restrict it for specific people or specific subnet to remotely manage these devices. So that's called standard access control list for VTY interfaces. So we've configured standard access control list for all the VTY interfaces. VTY interfaces are the interfaces where the SSH session takes place. So before any SSH takes place on this interface, they will first check what the access control list says. So if your IP is not here, you are being denied. But if your IP is here, you're being allowed on the VTY interface. All right. So number 16, configuring telephony service or the IP forms. So like I mentioned, The IP phones are controlled by this guy here. And this is the subnet of IP phones. Here also, it's here also. So it's this guy that distributes IP address to IP phones as well as distributing line numbers. So if I just put my cursor over this IP phone, you can see it has a line number of maybe line number 1003. If I put my cursor over this one, you can see it has a line number of the second last line number 1004. This one 1005. So it's the Cisco voice gateway that allocates those numbers, as well as facilitating dynamic IP address allocation. 17. Configuring WLAN network, wireless LAN controller, and wireless lightweight access points. So traditionally, we had what's called independent access points, like a TP-Link. If you have a TP-Link maybe around your homestead, you'll notice that if you have 10 TP-Links, then you need to configure each and every one of them. Just need to log into each TP-Link and configure. But to provide that kind of central management, and to eliminate that kind of manual and time-consuming management, we need to include what's called wireless LAN controller here. So the wireless LAN controller is the one that is responsible for centrally managing all the access points. So you can see we have a lot of access points actually in every department. So these access points are managed by Cisco wireless LAN controller. So every configuration we do here, we don't touch these guys here. So our job is to connect them to the switch, and we don't care where they are. What we do, we just configure everything here. As long as we position them where we want them to be, we don't need to go there. We don't care to go there anymore. We just configure everything here. If I want to configure some parameters for this one, I don't come here. I just set to this and do the configuration from this point. It centrally manages all these access points, right? So the firewall part. Okay. All right, so number 18, number 19, 20, 21. All right, the firewall part. So firewall is one of the most challenging parts in Cisco Packet Tracer, because what we may need to implement in Cisco Packet Tracer sometimes is not supported or incompatible. So we need to deal with the resources that we have, the little resources that we have. So in this regard, we had this firewall to separate our network. When you have a firewall, it separates the network or segments the network in different zones. So in firewall, we have what's called inside zone. So inside zone is where your users are. This is where my users are, inside zone. So before my users get outside, they must pass through the firewall. Then where I'm placing my servers is called demilitarized zone, DMZ. But where our customers are or the strangers are is called outside zone. So in firewall, there are concept of naming interfaces. So we make this interface, which is gig 011, named as inside zone. This one we name as DMZ zone. This one we name as outside zone, so that the firewall knows that our users are down here are on this side. Our servers are on this side. The strangers or customers are on this side. Yeah. So another thing that we need to implement there is firewall object network and network address translation. Right. So as you know, uh, due to limitation of IPv4 addresses, um, engineers came up with what's called NAT, Network Address Translation. So with NAT, you can access internet. I mean, million people can access internet via one public IP address, just different ports being used there. So we have to implement NAT on the firewall and tell firewall that whenever someone wants to go outside, please use this IP address. That's the public IP address that we have. So we implemented NAT here and directed it to use outside interface or outside interface, such that when everyone is from inside is trying to go outside, the firewall will say, oh, we need to use this IP because that's the one that is being NATed. So the firewall will translate the private IP address into public IP address while accessing the internet. But when the traffic is coming back, the firewall will translate the public IP address back to the private IP address. Okay. And number 20, Cisco ASA firewall OSPF and default static route. Okay, it's very important. Although in a real world situation, we rarely implement OSPF on the firewall because the firewall is smart enough to learn the routes and apply them. So what we normally implement on the firewall is static routes. We tell the firewall that whenever you receive traffic, remember the firewall is having route tables, but we tell it that whenever you receive traffic that does not match any entry in that routing table, then forward that traffic via the outside zone, outside interface. So we implement static routes like that. When the firewall receives traffic, maybe it doesn't match anything close to the firewall, it doesn't match anything in the firewall's route table, the firewall will be wise enough to forward it to the SP router. So we tell the firewall, if you receive any traffic that doesn't match your routing table, forward it to the ISP router. So the ISP router knows where to forward it. Yeah, and as well, we implemented OSPF in this scenario in the firewall. Yeah, but I would like to say that in the real world real world devices, or maybe in our next projects, we'll start ignoring OSPF on the firewall. I'll just do static routes. But being that this packet tracer, it has a lot of limitation, we just need to do OSPF or go the long way of doing static routes to and fro. Yep. All right. So finally on the firewalls, we do inspection policies to filter traffic. Well, the purpose of firewall is to filter traffics. Firewall will block bad traffic and allow good traffic. So in the firewall, here, we've only configured firewall to allow specific traffic, like allow specific services, like ICMP services. ICMP basically is used by ping. If you want to ping, you use ICMP. Another one is HTTP for web and HTTPS for web, as well as DNS. And finally, DHCP. So we have allowed how many services? DHCP, DNS, web, ICMP, and I can see email server also here, and maybe FTP service. So I'm going to show all of that practically. And that's now the end of that theory. Host device configuration. When I mean host device configuration, is like when you come here, you name this laptop as HR laptop, you name this smartphone as marketing smartphone, you name this IP phone as IT this is access point. You name it as IT access point. This one also you name it as IT phone, etc., etc. And finally, we need to go under testing and verifying network configuration. Okay, so now we're going to go into the configuration part, the practical part, where we're going to start. I'm going to start showing you whatever we have implemented here. So the first thing, maybe can you read it from your hand about what was my first requirement? You are sharing it. The requirements. I could see you had them on a notepad. Yeah. I just want to see know this first step, the second one, then I show you one by one. Okay, no worries. Please send me. If you sent me, just let me know so that I can download them. Okay, let me just do that. Okay. Okay. So here it is. Network design and beautification. It's all here. It's always important that you actually beautify the network design by using different colors and borders. And also check the second one was basic setting to all devices. So let's start showing you the configs. All right, so basic settings, we had a lot of basic settings as per the website here. The website here asked us to do basic settings like here, configure OSM, console password, enable password, banner messages, encrypt all password, and disable IP domain. Okay, so I just use one device to show you that. Yeah, so I'll just use maybe this Cisco switch. All right. So when I try to access this switch, it asks me for password. So this one is called console password. Yeah. So all my password, I think I normally use Cisco, lowercase, Cisco. Yeah. So when I log in, it takes me to this console, this management plane, this management window. So just go to enable. Then this is now enable password. Before we access the global configuration mode or the privilege exec mode, we should input the enable password. So also that means Cisco. Yeah. So this one is user exec mode, and this is now a privilege exec mode. So if you want to go to global configuration mode, we just say config T, and now we're in the global configuration mode. And how do we show all the configuration? Just say do show start. Do show start, and you hit enter. All right. So when you say do show start, the first thing here, we have the username here. Then we have enabled password here, encrypted. Then we have IP domain name here, and we've disabled domain lookup as well as we have username and password, which are the password is encrypted. So this one actually I will explain it later. This one, yeah, the two. Those are useful as a set, but I'll explain them later. All right. So we were actually talking about basic settings. Yep. So also you can see banner message. Well, banner message is kind of a guide that you inform your users or the engineers that unauthorized access to this device is punishable by law. As well as we have V2I interface. We've configured the V2I interfaces with password. Yeah, so I think that's the basic settings that we have there. And now VLANs. Well, like I mentioned before, we should have 3 VLANs. One for wired, wireless, and voice. So for VLANs, you can use any switch, any of these switches. So as I'm still going to use this switch. And how do you show VLAN? Just say do show VLAN. So here you can see the first VLAN is VLAN 50. That's called LAN for wired. Then we had another VLAN 60 called WLAN and associated interfaces. And finally, we had VLAN 101 called VoIP for voice and associated interfaces. Yep. So in this scenario, let me just say do show start. In this scenario, you will realize that in every port, it has both data and voice VLAN. So for example, let's start by, we now talk of access ports. Access ports are the ports connected to the end devices. But trunk ports are the one connecting the switch to switch, the two. These are now trunk ports. But the remaining one are access ports. So when we talk of access ports, let's just, for example, take port 3. You will see that this port has both data and voice VLAN, such that that port can either be connected with a computer or IP phone. It can accept both IP phone or computer. It has 2 VLANs, but one is called data, another one is called voice. Right, so for VLANs, this is the command. And to know which particular, to show them in config, just say do show start, and here they. Yeah. All right. Okay. So another thing that is here that we need to do, to check on, is EtherChannel, spanning tree protocol, and BPDUGuard. Spanning tree protocol port first and BPDUGuard. Okay. So let's start with the EtherChannel. Well, EtherChannel is a protocol that aggregates multiple physical ports into one logical channel. So for example, you see between this switch and this switch, we have 2 interfaces, as well as this one and this one. as well as this one and this one. So to achieve more redundancy and more bandwidth, we need to implement EtherChannel. And as well, EtherChannel prevents loop. So EtherChannel will combine these two interfaces. We'll assume that they are one logical channel. It will combine them into one logical channel, although they are two physical interfaces. So how do we show EtherChannel? So I still use this switch because all of these things are implemented in a switch. So you can use any switch that you like. So to show EtherChannel, yeah. So here, okay, do show EtherChannel. All right. So here you can see we have what's called LACP. LACP is Link Aggregation Control Protocol. Is a standard EtherChannel protocol. So you can see it has used 2 ports. And the maximum number of ports that we can use is 16. And the port channel that we have is only 1 because these 2 has been aggregated into 1 channel. So to show you more about that, let me check if there's any. Okay, the channel. Okay, all right, no worries. So to show more about them, just say do show start. Okay. So for either channel, we implement them on trunk interfaces. So we implement them on trunk interfaces. So these are the trunk interfaces. So that's where we've implemented either channel. So you can see switch port mode trunk, channel group 1 mode active. So for LCP, we use active passive modes. So on this side, I used active. Maybe on this side, I use passive. So to maybe bring to show more about that, let me just go to this switch. So this switch actually aggregate channels from different switches. So it has 3 channels, 1, 2, 3. So let's just show it here. Yeah, so you see this one is having 3 the channels. Yeah, because it has formed either channel association with 3 other switches. But for this one, it's only 1, this one and this one. Yeah, so if you can also say do show start, you will notice that for the trunk interfaces, this one, they have either channel configuration here from this point where the active starts, where the port channel group 3 mode active. Yeah, active. So those are the either channel configuration. Then another thing that was mentioned here was STP spanning tree protocol port first and BPDUGAD. Like I mentioned before, demonstrating here that with the port first and BPDUGAD, we can fasten the port transition from blocking state to forwarding state. So immediately we connect, it turns green. It doesn't go into transitioning stages like blocking, learning, etc., etc. Yeah. So how do I show that? Just come here. Do show start. Just say do show start. So like I mentioned, we only implement them on access switch, access ports. So from the access, where you see any mode is access, you will see port first and BPDUGAD. Port first and BPDUGAD. And the purpose of the two is to fasten the port transitioning from blocking to forwarding state, as well as blocking or preventing any loops from occurring in the network. Okay, so subnetting and IP addressing. Okay, so for this one, I'll not go deep into it because we already have them here. So for wired users, actually it was also explained. It was also explained here. on the documents here. Yeah, so for wired users, we should ensure that in this subnet. For Wi-Fi users, that subnet, all IP phones there, and servers to be in that subnet, the DMZ, and Inter-VLAN routing. So Inter-VLAN routing, like I mentioned before, we implemented two types of Inter-VLAN routing here. One is switch virtual interface on this switch. Another one was route on a stick on this guy. So let's start with the switch virtual interfaces. So for Inter-VLAN routing, remember, Inter-VLAN routing is trying to enable devices from different VLANs to communicate. So in this network, we had how many VLANs? 3. We had data VLAN, LAN, wired VLAN, wireless VLAN, and voice VLAN. So we are going to implement the VLAN routing here. So in that case, we are going to create sub-interfaces or VLAN interfaces. We are going to create VLAN interfaces. Yep. So here are the VLAN interfaces. Yep. So provided that, as mentioned, that the voice gateway here will deal with voice VLAN. So we don't implement voice VLAN here on the core switch, because we want the core switch to only deal with the data VLAN, both wired and wireless. Yeah. So as you can see, we created two VLAN interfaces. This is for wired users, and this is for wireless users. You can see the subnet starts there. Yeah. Then here we tell these interfaces that, I just wanted to pay close attention here. Every device that is under this network, every device that is under wired users will report to this guy. This is their default gateway. Every computer or printer connected over network or over cable with a cable will report to interface VLAN 50 as their default gateway, as well as any wireless device that connects to the network will report to interface VLAN 60 as their default gateway. Then here also it mentioned that Inter-VLAN routing plus IP DHCP helper addresses. Okay, provided that the DHCP is here. So we need to tell this VLAN interfaces that whenever someone is looking for IP address, report it to this guy. Forward that request to this guy. So for example, this computer is looking for IP address. First, it will report to this interface VLAN 50. Then interface VLAN 50 will realize that someone is looking for IP address. Yet it's not a DHCP server. So the interface VLAN 50 will check on its configuration and find that the DHCP server is located here. So that request will be forwarded to this guy here. The same will apply here. Okay, so another thing that okay. Number 6, static IP addresses to DMZ or server farm devices. So for servers, it's always very important that we implement static IP addresses, because we cannot do dynamic IP address. Servers, we had code them somewhere. So it's always very important that we configure static IP address. So how did I do that? Just click on the server, you go to config, or just come to desktop, then IP configuration, and this is where you do it. Yep, so that's how it's done, pretty much easy. Then DHCP server configuration. So, like I mentioned, this is a D server, Active Directory server is our DHCP server. So how do you configure a DHCP server? Just go to here and you go to services, then under DHCP. So here you can see we have two pools. One pool is for LAN or wired users. And you can see the default gateway is the IP address of the sub interface here. Okay, let me just put this one here. Put this one here. So this is for wired VLAN or wireless wired users. So the default gateway, I said that whenever someone who is connecting via cable wants IP address, they will report to this guy here. So that guy will say, although I'm not the DHCP server to grant you request, but I can forward you to this guy. So when it forwards you to that guy is this AD server. So you can see the AD server is having that IP address. Where it is, the IP address here. The AD server is having that IP address. So the guy will forward you to AD server, which is here. So when it forwards you to AD server, it will find this configuration. It will need to find that there's a pool that can grant your request. And the pool uses default gateway as this one here. And DNS server is just the AD server itself. Then we say that start allocating IP address from maybe .11, because from 10.1 to 10.10, maybe we want to assign other things internally. Yeah. All right, so that's done. Another thing, another pool that we had is VLAN pool. So for VLAN pool is its configuration. So anyone connected via any wireless means will report to this interface here, interface VLAN 60. And if that guy wants IP address, the interface VLAN 60 will say that although I'm not DHCP server to grant that request, but I'll forward you to this guy. So that guy here, that guy is the AD server. So when the request goes to the AD server will find that there's a pool that can grant that request. So you can see clearly everything is there, like we mentioned. Yep. So that's also very important. Yeah. And another thing for wireless pool, it's always very important to specify the IP address of wireless LAN controller. Although this one will come later, not in this concept. Yeah. So anything else? Okay. OSPF. Well, OSPF, like I mentioned, has been implemented on the firewall, the routers, and the multi-layer switch. So, for example, let me just go to this multi-layer switch here and show you the OSPF configuration. You just say do show IP OSPF. Okay. All right. So I just want to show you neighbors. Do show IP OSPF neighbors. Yeah. Right. So you can see the switch there has been configured OSPF where the interface, it has formed neighbor with via the interface of gig 101. So gig 101 is this one, I think. Yeah. So it has formed neighbor with the firewall. So just let me just do it here. I think here will be okay. Show IP OSPF neighbor. Seems like I'm forgetting that command. This is in do show IP OSPF neighbor. I've been focusing on cloud issues. I've been focusing on cloud of late, and I forgot some of the Cisco commands. Yeah, so just a minute. But this is what I did. Let me just do that again. Show IP OSPF neighbor. Okay. Okay, so let me check that. Okay, just a minute. Damn. Okay. All right. So let me just show you. I think I'll get that command later, or maybe we can use ChatGPT. Let me see. I forgot that command. I actually I was focusing on cloud of late from June last year. I've been doing cloud things. Okay, let me see this. Show OSPF neighbor. Okay, it's not accepting. It's not accepting. So maybe I'll do that. And it. Okay, so I'll just show you where the neighbors have been formed. You can see here, the neighbors have been formed here. But on the router, for example, on this router, I think now it will be clear on this router than anything else. Show IP or SPF neighbors. Yeah, so on this router, you can see we have two neighbors here. One of them takes the firewall. Another one is via the ISP, this network. So that's how to show OSPF neighbors. And as well, you can just say do show start. So when you do show start, you will see OSPF configuration at the bottom of this configuration. So here's the OSPF configuration. So we're seeing OSPF, the process ID of 35, and route ID, that one is a default setting. It comes on its own. Then we advertise all the networks connected on that MAC layer switch with the area 0. Okay, so let me check another thing that we make here. Firewall interface security zones and levels. All right. So let's go to the firewall and show start. So firewall interface security zones and levels. So in this firewall, we had 3 interfaces. So let me just mark the 3 interfaces. Good. So for the first interface, which is gig 1/1, is this one. has been named as inside, and the security level is 100. Well, the security level dictates the level of trust we have per zone. So for our inside users, we normally trust them as far as firewall is concerned at the firewall level. So we just mentioned that's a security level of 100%. We trust them 100%. Then we we specify which IP address to locate it. So there are three configurations that we need to do here. First, we specify that that's an inside interface so that the firewall knows that that interface is where the end users are. Then how do we trust that interface? We trust it 100%. That's our users are. And what's the IP address of that interface? This one. Then we go to gig 1/2. Gig 1/2 is the interface connected to our servers, the DMZ. We just name it as DMZ so that the firewall knows that's our servers are, that's where our servers are. Then how do we trust where our servers are? We can't fully trust them where servers are. We trust it maybe partially, 70, 50. It depends on the value that you input there. And you place the IP address there. And finally, the outside interface, the one connecting to other strangers or customers. You name it as outside interface, then you cannot trust because that's where hackers come from. You give it a security level of 0 and you input IP address. So that's done in regards to firewall security levels and zones. Number 10, now let's do inspection policy. Like I mentioned before, that in this firewall, we are only going to allow limited number of services. And let me show you the services that we have allowed there. You're not going to allow everything. So if I scroll down, the command is still show start. In firewall, we don't use do, it just show. Yep, so here it is. Now this is the inspection policies. So you see in this firewall actually, because this packet tracer and we have limited capabilities, we cannot implement everything that we want in packet tracer. So in this regard, I was just kind of applying policies to everyone. That access list, that one, access list, this one is an extended access list, then permit ICMP from anywhere to anywhere. So even hackers actually can ping our network because of the limitation of packet tracer. If we did advanced firewall policies, then we could have run into problem. So ICMP is for ping. Then let me mark the 2. Yep. So here in the two policies, I was permitting UDP protocol from any network to any network, then equal to port or protocol boot PC and boot PS. Boot PC and boot PS are for DHCP, 67 and 68 port, UDP 68 and UDP 67 ports. Those are for those are used for DHCP. Then allow me also to mark the 2. I'm allowing UDP port or service domain and as well as TCP service domain. DNS uses 2 ports, two protocols, both UDP and TCP. So you have to allow all of them here. Then now these are now for web. You can allow those ports. www for web, port 80. Then you allow port 8080, port 443, port that one. And also you permit that one. And that's how you actually implement firewall policies. Just allow which particular service or port you want to allow. Okay, then number 11, standard ACL for SSH. Standard ACL for SSH. So for that one, and another thing that maybe I forgot to mention on the firewall is NAT. So here is the NAT configuration. This is how we implemented NAT. We create object network and bind them to, especially the NAT to use from inside to outside interface, and use dynamic interfaces. As well as we have static route here on the firewall. Then let me see. And finally, OSPF also we implemented on the firewall here. All right, so let's do standard ACL for SSH. Okay, so for that I'll demo with any switch. Okay, I'll demo with this switch. Standard ACL for SSH. First of all, do show IP SSH. So you have to show whether OSPF has been, SSH has been enabled or not. So you can see SSH is disabled here. Okay. Let me go to access switches. Maybe I forgot to do it there, but it should be on the access switches. Show IP SSH. Oh, so SSH has been enabled, been disabled. Okay. How did I forget to implement SSH here? Let me try it here once again. Okay. Seems like I forgot to implement SSH. So I'll skip that point. Okay. Okay, so okay, seems like in that project I forgot to enable SSH. Okay, but I could see there are a lot of SSH configuration in this. For example, this one, these are used for SSH. Okay. All right. So for that point, I'll skip it because seems like I forgot to enable SSH. Now let's go to wireless network configuration. So in this network, like I mentioned before, for wireless infrastructure, we're using this guy, Cisco Wireless LAN Controller, to control our wireless system. So it's this wireless LAN controller that will configure each access point with the SSIDs and passwords. So I don't know whether I still remember the password of this wireless LAN controller. I'll just try, but it's been very long. So I'll just copy that IP address and use any computer from IT support. Go to web browser. I don't think if I can remember the password of that wireless LAN controller. Okay. Yeah, I think that will be okay. Okay. So you have to ensure that it's HTTPS. Okay. What's the admin? Is it admin? Oh, okay. And password is Cisco at 123. Okay. Okay. It's perfect. Got it now. I couldn't have remembered that. Yeah, it's been very long since this project was implemented. Okay. All right. So in this infrastructure, this is the wireless LAN controller that controls everyone, every computer. So ensure that you log in from senior network engineer PC, which is this IT support PC, and then the first thing to check is the wireless part. So when you check on the wireless part, you will see all the access points that are here. They are actually managed here. As well as you go to VLANs here, and you see we have two Wi-Fi networks, telco guest, telco amp, and telco guest. So if you just put your cursor over any access point, you will see that it's providing two Wi-Fi networks, telco amp and telco guests. So another thing that I can mention here, okay, I cannot see this. Okay, let me see. And then go here. Okay, VLANs. Okay. So okay. So for example, let's say you want to maybe change the Wi-Fi name here. Just click here. Just click on there. Maybe just wait for a few minutes. This packet is normally hang when it comes to wireless LAN controllers. So maybe you want to change the name of the Wi-Fi name. I mean, you want to change the Wi-Fi name. Tempo test 123, and just apply here. Okay. Okay. So when you come, maybe if you just try to check here again, you will now see it has changed to telco test 123. So it's very, very important also to check that. So for this method of wireless LAN controller, I didn't do much. I have a video on YouTube where I did a lot in regards to wireless LAN controller. Yeah, so I did a lot in regards to wireless LAN control. Let me just go there. That's actually the most advanced method of configuring wireless LAN controller. So this method 3, this is the best. Remember, this project was recorded using method 1. Method 1, which actually which was recorded a long time ago. So you should also go ahead and watch method 2 of wireless LAN controller as well as method 3. The best one is method 3. Method 3. Yeah. So so this project I just used a very basic method of wireless LAN controller. It's not even method 2. So this was method 1 of wireless LAN controller configuration. So for maybe your own benefit, you should go and look for method 2 and method 3. So the best one is always this one that's currently used in the market, method 3. Yep. So another thing that I can mention in regards to wireless LAN controller, okay, I'm just letting you know that everything is done from this point. If you want to configure Wi-Fi name, you want to configure Wi-Fi password, we do it from this point. And how do we log in from there? You just come here under management interface. You copy the IP address. Then you come to this IT support PC. Then you go to web browser here. Then that's where you actually put the IP address. So ensure that when you put the IP address, when you just put it this way and you try to run, you will encounter issues. So just ensure you do it as HTTPS. So when you run it that way, you get this one. Then you log in and check 1, 2, 3. Okay. All right. So telephony service configuration. I think that's one of the last part. For VoIP, it's always this guy here. For IP phones, we do it from this guy. So when I go to that guy and I say do show start. So start. So the first thing you do, you say that it's the Cisco gateway that will act as the DHCP server for IP phones. So we created IP pool here, DHCP pool here, that will allocate a dynamic IP address to all the IP phones here. So you will notice that the IP address assigned to the IP phone there is in this range. So one thing that I've noticed that I didn't include here is the default gateway. You see, the IP phones do not have default gateway. So maybe you will add that later. Config T. Adding it is very easy. Copy. You just enter into this pool and say default router to be the IP address of this interface. The IP address of this interface, which is FA00, FA10, 172.16.10.1. So default router there should be 172.16.10.1. Exit, do right. Okay. So if I can just say and show start again. Oh yeah, so you'll see the default router is here, which is very important. So I was just informing you that it's very important to configure DHCP pool for the IP phones. That's our DHCP pool. And then, okay, so that's our sub interface. For intermittent routing, we need to do sub interfaces. We assign IP address to the sub interfaces. So we did there. We created a sub interface that's called FA00.101. So 101 was the VoIP VLAN. So you can see encapsulation.1Q101, which matches the VoIP VLAN. And then now the telephonic part comes in. So this is where we start configuring telephonic services. So telephonic service, we see that maximum number of IP phones that we have is going to be 10. So create 10 directories for these phones, and also the source IP address should be the source IP address should be the IP address of this interface. This is our default gateway. So you are telling the telephonic service that the default gateway is this interface here, and normally it uses a standard port of 2000. And I would assign any phone from number 1 to number 10. So these are the phone number. Phone 1, number 101001. phone 2, 1002, phone 3, that one, and this one. Then these are now being generated automatically. Yeah, those are now generated automatically. This one. Yep. All right. So having demonstrated all the practical aspect of this, now allow us to test. And the first thing that I'm going to test, I'm going to test DHCP. So DHCP, for example, let me just take this computer here. Come to desktop, IP configuration. Currently using, it's on the DHCP side, and the IP address is here. So to test DHCP, just come to static and back to DHCP. And maybe give it some few seconds. You can see DHCP request successful. So that request has gone from this computer to this switch, from this switch to this multi-layer switch, from this multi-layer switch to this firewall. The firewall will forward that request to the AD server here. Right. Another thing that I would like to test is communication from inside the network to outside network. We want to see if we are able to access the Azure virtual machines here. So maybe you try to ping. In that regard, we just use ping. As long as we can reach it via ping, then we can reach it. Ping. The IP address of Azure virtual machine, I think it's if I put my 30.30.30.10 ping 30.30.30.10. Just maybe wait a minute to see the results. Yep, so you can see it's actually pinging the Azure virtual machine. And another thing that we need to test is actually we've tested on how to maybe replace Wi-Fi name and password. I've shown you how to do that. So let's just try to use IP phones here. So for example, this guy, cloud engineer, wants to call HR. So what we do, I just take that one, put it here, I go to GUI, then I go to cloud engineer guy, put it here, I go to GUI, okay. So when you see clearly, the extension of this guy is 1003. The extension of this guy is 1006. So let's assume this guy wants to ping this guy here. So just input the extension here, 1003, and you call. So you see it's ringing from on this side from 1066. Ringing out. So if you can just pick it, just click here. So you see it's connected. It's connected. The extension is here is 006 to 1003. It's connected. Extension is 1003 and it has received a call from 1006. It's connected. If you want to hang up, just hang up. And also let's try to call 1006 and see. You see this guy is ringing. Pick up and disconnect.
Okay.
Yep. So another thing here. Another thing. Let me see. Maybe anything that I implemented. The DNS side. I didn't implement any DNS thing. Okay. An email side. Let me check. Email. I didn't implement email. FTP service. I didn't implement any. Oh, I implemented FTP here. This is actually default. I didn't implement. This is a default implementation. All right. So Let me check anything that I can mention. Okay, so I know, and sometimes you may wonder why a computer from this point is connecting to access point here, yet it had an access point on this point. Let me explain that. These access points have been configured to provide available Wi-Fi's. All of them are providing same Wi-Fi names. So this is packet tracer, and it's very close to each other. So the device will only connect to access point where it has considered is having much bandwidth, or let me see this what's called signal strength. Yeah, so this phone here, consider this access point having more signal strength than this one. But if maybe now we place them physically, it will now force this phone to connect this one, because this is the one that is close to it. Now this is packeted now, and it should not maybe bother you in regards to which smartphone connects to which access point. Yeah. So maybe if you have any question that maybe I can answer, please let me know. Oh, no configuration. Here, what we did was just to, here is just a router. See, just a minute. Okay, so let me take this delete and uncluster. So this is just a router. It was just a router. So it's only just that I made it look like a cloud in real sense, but it's just inside. It's just like you just covering something, but inside is a router. So what I did there is just OSPF and IP configuration. Well, Packet Tracer doesn't support third-party applications like Azure and so on and so on forth. So we just represent them maybe using some icons. Yeah. Yeah. So any other thing? Yeah. Thank you so much. And as well, I'm going to share this video with you. I'm going to put it on my YouTube channel and make it be private, and share with you so that you can watch it. Uh, Thank you so much, and have a good day. Bye bye.